Paper we're diving into today is called The Structural Roots of a Unified Theory of Everything, an MLT-based dimensional ancestry of physical law by Joey Lawson.
Right, and honestly, that's an ambitious title. Trying to root out the foundation for the so-called theory of everything. So, right up front, what's the big question Lawson's trying to answer here?
Essentially, he's challenging that whole modern physics tendency to invent ever more complex particles, new forces, and extra dimensions just to tie everything together. Instead, his question is, what if we already have the skeleton for unity, hidden in the basic structure of the equations we use, like, say, Newton's good old F equals ma?
Exactly. It's about the ancestry of physical law, and Lawson introduces this approach he calls origin homology, which I guess is like looking at where physical laws actually come from, not just what they do now, but how their structure is inherited over time.
Right, like a family tree for equations. And his claim is that all known force laws, gravitational, electromagnetic, strong, and weak, ultimately have the same dimensional identity. That's the whole MLT thing: mass, length, time. Every force, when you boil it down dimensionally, is MLT to the minus 2.
Yeah, so if you take Newton's force equation, force equals mass times acceleration, and you write out its units, you get exactly that, mLT minus squared. And Lawson argues that this template isn't just for classical mechanics, it's inherited by everything, including like Einstein's E equals mc squared.
Which is pretty wild. He actually goes through step by step deriving that famous equation, showing that if you push the velocity in Newton's equations to its limit, you naturally get E equals mc squared emerging. It's less revolutionary leap and more structural descendant in Lawson's eyes.
His approach is kind of refreshing because it says maybe the unity physicists crave isn't just waiting in the next big particle collider. We might already see it every time we plug numbers into these familiar equations. The differences between the forces, Lawson says, are mostly just the constants in the way we apply the basic formula, not the actual skeleton underneath.
And that has, I think, a pretty interesting implication for how we view science as a whole. Like, is science about inventing new things or recognizing what's already sitting right under our noses? Maybe it's both. And sometimes, I don't know, sometimes it feels like we get distracted by the new and shiny and miss the, basic patterns that tie everything together.
I mean, honestly, I sometimes spend more time looking for my car keys than noticing the new plant in my apartment. So I guess it's a pretty human thing to do, right? Look for something big and new, when maybe the unity was there all along.
Exactly. Science and car keys. But to get back on track, Lawson's techniques, using units of measurement, dimensional analysis, and tracing formula derivations, all basically show that regardless of how fancy our physics gets, those bones are always the same.
For listeners, I think that means don't treat science or physical laws as some mystical, flawless truth, but as an evolving structure. This paper is one way to reflect on the skeleton, so to speak, what we can learn by comparing the structures beneath all the physics we know.
Sometimes these new frameworks, like origin homology, won't overturn how we see the universe, but they challenge us to zoom out and appreciate the architecture behind all the details.
For sure. So, to sum up, Lawson's not overthrowing physics. He's pointing out the deep inheritance connecting every theory we use. Maybe the real theory of everything is the structure tying them all together.
Couldn't have said it better. And I guess, whether you're a physicist or you just appreciate how ideas evolve, there's something comforting in realizing just how much our weird, sprawling universe is built on a handful of sturdy roots.
Definitely, PA. Let the equations inherit the Earth, or at least unify it.